Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter rotational motion. This is part 9 of the video. Kindly do visit the previous parts also so that you can understand the problems on rotational motion clearly. This is the first problem. It is saying a uniform rod of length 200 centimeter. Okay, that is this is 200 centimeter. Okay, the uniform rod of length 200 centimeter, okay, and mass 500 gram mass is given. Okay, now if this is 0 centimeter, this is 200 centimeter, where will be the mass of this rod? Here, this is center of mass. Okay, this is center of mass. Okay, this is 0. Okay, starting from 0 to 200, where this will be 100 centimeter. Now the weight of the rod will be downwards. Okay, W is equal to mg, and this is force F is equal to m into g. M should be what? In this is 0.5 kg, right? 0.5 kg. 0.5 kg into 10 is g is 10 meter per second square. That is 5 Newton. Okay, 5 Newton. And this will be around right on the perpendicular distance from the wedge. If this is 100 minus 40 will be 60 centimeter. You are supposed to calculate the torque here. This is the wedge. Now, okay, and a wedge placed at 40 centimeter mark. Okay, a mass of 2 kg. What will be the force here? Is weight 20 Newton, and here also there is a mass mg. Okay, right? Mg weight force downwards. Okay, and if this is 20 centimeter, this is 40 centimeter. These perpendicular distances are very important. Okay, 40 minus 20 is 20 centimeter, right? And from here again to here it will be how much? 160 minus 100 means 60 centimeter. Okay, wherever we saw weights, that is 2 kg m, they have written 20 Newton forces downwards and acting towards downwards, 20 Newton and mg. And this is 5 Newton. That is very, very important. This is mass of the rod is how much they have given? 500 gram, and the force will be acting downwards. Weight of this rod of mass 500 gram, that is 0.5 kg. 0.5 into 10 is 5 Newton. Right. Now, this is find the value of m such that the rod is in equilibrium. The rod is in what? Rotational equilibrium. Rod is in rotational equilibrium. Means to say net torque must be 0. Net torque must be what? 0. That is torque clockwise will be equal to what? Torque anti-clockwise. Okay. Where exactly you are supposed to calculate the torque? About this wedge. About this wedge you are supposed to calculate. Now, let us calculate the clockwise torque first. Now, this perpendicular distance is 60 centimeter. And how much is the force? 5 Newton. Okay, that is perpendicular distance. Convert this into meters. 0.6 into what is the force? Force 5. Now, plus of this is clockwise. This is clockwise, and here also there is clockwise torque. And what is the distance from this wedge to this mass? 60 plus 60 is 120 centimeter. 120 means 1.2 meter into what is the force? mg. Okay. Now one more force is there here, that is acting what? This torque will be acting anti-clockwise direction. Okay, that is equal to what is the distance? 20 centimeter, that is 0.2 into what is the force, that is 20. Hope you understood this one. Okay, this is what these two are clockwise starts. This is anti-clockwise start because the forces are here downwards. 5 Newton, and this is the weight, that is force mg. Okay, this is downwards and the clockwise torque is acting here anti-clockwise. If I refer to this point weight, now you are supposed to calculate m. 0.6 into 5 3 plus of 1.2 mg. 0.2 into 20 is 4. Now you are supposed to calculate 1.2 mg is equal to 1, m is equal to 1 divided by 1.2 g, that is equal to 1 divided by 1.2 into 10, that is equal to 1 by 12 kg is the right answer. Hope you have understood. 1 by 12 kg. What is the value of m? Value of this, okay, weight, that is mass, is how much? 112 kg. Next problem you see. What is this? A uniform ladder of length 5 meter. Okay, this is rod. Okay, uniform ladder of length 5 meter. Okay, this is, we will think this as a rod for the timing. Uniform ladder of length 5 meter is placed against the wall as shown in the figure. The coefficient of friction is mu. Okay, is same for both the walls. What is the minimum value of mu for it is not to slip? This rod or ladder, it should not slip. What is the minimum value of mu you are supposed to calculate? Dear students, there is a short trick for this one. Use the formula tan theta is equal to 1 minus mu square divided by 2b. Where is theta? This is theta. This is theta. Okay. How much is tan theta here? Tan theta is equal to perpendicular by base, that is opposite by adjacent, that is 4 by 3. Now we can use, okay, substitute this here. Tan theta is how much? We got 4 by 3, that is equal to 1 minus mu square divided by 2 mu. Now that is, we'll cross multiply. 8 mu is equal to 3 minus of 3 mu square, or 3 mu square plus of 8 mu minus of 3 is equal to 0. If I multiply this and this, that is equal to minus 9, I am going to get. Minus 9 means minus 9, I get 1/8. That is, I can use what? 199. I can write minus here. Why? Because I have to get 9 minus 1 plus. Okay. Now you are supposed to simplify this quadratic equation. 3 mu square plus of 9 mu I can write, minus of mu minus of 3 is equal to 0. Okay, 3 mu I will take common, mu plus of 3 I can write, minus I will take common, mu plus of 3 is equal to 0. Mu plus of 3 you can take common here, 3 mu minus 1 is equal to 0. Mu is equal to minus 3, you omit this one, okay, omit this one. 3 mu is equal to 1, mu is equal to 1 by 3 is the right answer. Okay, mu is equal to 1 by 3. Students, hope you understood. Whenever you get a problem like this, use this short trick. Tan theta is equal to 1 minus mu square by 2 mu. Hope you understood this problem. Okay, we will see the next problem. Two constant parallel forces act on a wheel. Okay, constant forces, this and this, constant. Therefore, torque will also be constant. Two constant parallel forces act on a wheel provided in a transistor for tuning as shown in the figure. If the wheel rotates, then your work done for rotation will be. Okay. Now we are supposed to calculate the torque here at the center. Okay, we calculate the torque. Now, how much is the torque? These two forces are magnitude. Forces are equal. Magnitude is also equal. if I take this will be how much? Perpendicular distance will be 5 by 2, 5 by 2 centimeter, and this is also 5 by 2 centimeter. This is the diameter they have given, this is the radius. Okay. Now torque will be equal to what? 2 R F. This is F. F. This is also called a couple because two equal forces are acting in opposite direction. Okay. Anyway, tau is equal to 2 into R is how much? 5 by 2 into how much is the force? 0.1. Right. This you are supposed to convert this into what? Meters. That is into 10 power minus 2. Hope you understood. Tau is equal to 2 gets cancelled. 0.5 into 10 power minus 2 Newton meter I got. Right. What you are supposed to calculate? If the wheel rotates, then the work done. This is torque is what? Constant. Torque is what? Constant. Now we have the formula. What is work done? Given by W is equal to tau into angular displacement. This is work done per rotation. Therefore, per rotation is equal to theta should be how much? 2 pi radians. Substitute this one, we get the answer. Work done, W is equal to how much is torque we got? 0.5 into 10 to the power minus 2 into 2 into pi. Theta is equal to 2 pi radian. Why? Because this is per rotation. Total 360 degree. That is equal to 2 into 0.5 is 1. 1 into pi is pi. Pi into 10 to the power minus 2. Pi is how much? 3.14 into 10 to the power minus 2. That is equal to, see the answers. That is 0.031 joule is the right answer. Hope you understood this one. Okay. Students, today this much only. Kindly work out the problems, practice the problems. The more you practice, the better you can do it. I wish you all the best for your KCET, NEET and IIT JEE examinations. If you like the video, kindly share with your friends. Ask doubts in the comment box. Do not forget to subscribe for my channel and like the video if you really liked it, so that I get motivated and put lot of interesting problems for you in the future, inshallah. Thanks for watching this video.